In this lesson, we're going to discuss the basics of working with arrays in C++. So an array is essentially just a list of variables where we use a consistent name for the variables and then distinguish them by a subscript. So think of in a math class where you might refer to x1 and x2 as being two different x coordinates. An array is going to work in a similar fashion in C++, where we just use subscripts to distinguish the different elements of an array from each other. So a situation that might lend itself to an array is where you need to store data of the same type, and you'd want to use a consistent name for that data. So let's say we wanted to store 4 grades. Now we could make 4 variables of type double, each with a slightly different name, or we could store the 4 grades in an array of doubles. So let's start by declaring an array of doubles for this. So we'd start by establishing the base type of the array, which in our case is double, so we'll use the keyword double. Then we'll give the array a name, which in this case will be grades. And then unlike a normal double variable, we would establish that this is an array by using square braces, and then typically putting the size of the array inside the square braces, which in this case will be 4. So we've just declared space for 4 variables of type double in memory in the computer, and told the compiler that we have this array called grades that will have 4 elements in it. So now that we've made this array, we can start to assign values to the elements of it if we wished. So the very first thing to get used to when coding with arrays is that array indices or subscripts always begin at 0. So that means the first element of this array will have a subscript of 0, and the last element of this array would actually have a subscript of 3 and not 4. Here, the 4 is used to establish the size of the array, and the last element will get referred to with a subscript of 3. So let's say grades square braces 0, we wish to give a value. So that will be the way to refer to the first element of the grades array. So notice the use of the square braces here is to distinguish the element, and here it's used to establish the size. They're being used in different ways. Let's give that element a value of 92.5. Now we could also assign the other 3 elements of this array values in a similar way. So let's do assignment statements for the other elements of it. So again, we're just assigning different values to the different elements of this grades array, up to the last one here, which we'll say is 95.4. So again, notice the first element of the array is referred to with a subscript of 0, and the last element of our grades array is referred to with a subscript of 3. That is 4 total elements, because 0 through 3 is 4 numbers. But those array indices must begin at 0, and will always be less than the size of the array, which in our case is 4. So now that we've assigned all 4 elements of value, we could do different things like printing them out, even changing those values. So let's say we wish to print out the first element of the array. So to refer to that element, we just simply refer to it as grades square braces 0. And it would treat this just like a normal double variable when it prints that out. It would know how to print that to that output stream. And again, when we run this, we just see that value of 92.5 print in place of grade square braces 0. And we could also change the value of some of these elements. So let's say we wanted to add 2 to the score for grades square braces 1. Do grade square braces 1 equals grade square braces 1 plus 2. We could also use the shortcut plus equals 2 for that as well. And then we could show the new value. So let's say the new value of the second element of the grades array is, we should see 84.5 print for that when we run this. So let's run it and see. Okay, great. So it just added 2 onto the original value of that element. So again, that just shows you some of the basics of declaring an array, assigning values to the elements of the array, and also printing out elements and also changing the values of elements through other statements. So another way that you can assign values to the elements of an array is when you're first declaring it and using a list. So let's say we wanted to make an array of integers this time. We'll use the base type int. We'll just call this array numbers. Let's say we're going to have space for 5 integers in this array. So rather than ending the array declaration there, in this same line, we can initialize the array using a list. So we'll use the assignment operator and then curly braces to identify that we're using a list. And we'll list out 5 values that we wish to assign to the elements of this array. So we'll do 2, 4, 6, 8, and 10. What the compiler will do is assign these 5 values in order to the 5 elements of that array, meaning the first element will get the value of 2, the second element will get the value of 4, all the way down to the last element, which will get the value of 10. And just to show you that that worked, let's print out the last element of that array. So we'll say the last element of the numbers array is, and that would be numbers square braces 4. Again, be careful with that subscript. The last element should be less than the size of the array, which is 5, and if array indices begin at 0, the last element in that array would have a subscript of 4. And again, when that runs, we see that the value of 10 was correctly assigned to that last element. Now, you can also use this list in different ways. You could also partially fill an array if you wish to, using a list. So let's say we wanted to make another array of integers. We'll do int, call this array more numbers, and say it still has space for 5 elements, but we're only going to assign the first 2 of them. We'll do 1 and 3. What happens is it will zero out the remaining 3 elements that we're not giving values through this list, which is kind of nice. It will actually just, again, initialize or assign the first 2 and then zero out the remaining 3. That ordinarily would not happen if you just declare it this way. Like, the elements of the grades array were not zeroed out initially here, but when using a list, that will zero out any elements that are not given values. So just to show you that, we'll say the 4th element we'll do this time of the more numbers array is, and again, the 4th element will be more numbers square braces 3. And what should print there is the value of 0, which it does. Great. Now, using this list feature, you don't even have to establish the size of the array if you're choosing to use a list. Meaning we could have left this empty in this line of code right here and not use the number 5, and the compiler would know, based on this list, that we need space for 5 elements. In this declaration up here that we initially used, we couldn't have just left that empty and then start referring to different subscripted variables. It's a slightly different situation there. But if you're declaring and initializing an array in the same line, let's say, so we'll do double more grades, you could leave the square braces empty when you're initializing with a list, and it will use exactly enough space as is needed for the task. So let's say our grades were 77.1, 85.4, and 99.1. In this situation, it will know that we need space for 3 elements in this array, and it will establish that when it first declares this array. So to show you that, let's say the first element, let's say, of the more grades array is, and we could refer to more grades square braces 0, and it will correctly assign that the value of 77.1, which it does, as we see here. So again, you're allowed to leave these empty when you're initializing with a list, but do not leave them empty if you're just declaring the array and not using a list to initialize it. You have to think of how many elements you need in your array in a situation like that. So one final thing to point out is that when arrays are stored in memory in the computer, they're stored sequentially, meaning these 4 variables in the grades array are stored sequentially in memory. And if you attempt to access an element that's out of range, meaning if you attempt to access a subscript that's beyond 3, or say even before 0, typically the compiler won't even warn you. And you can see either a garbage value printout or sometimes your program will crash entirely. So be very mindful of not going out of range or out of bounds of an array when you're coding with it. So just to show you that, I'm going to put a little comment here that do not do this, but I'll show what happens when you do attempt to access an element that's out of range. We'll say accessing an element of the grades array that is out of bounds or out of range. Let's attempt to access grades square braces 100. So clearly that exceeds the allocated space for the grades array. We had space for 4 elements, which means the subscripts we could have referred to as 0 through 3 And what's going to happen is it's going to keep reading in order past that last element and try to find wherever it thinks the 100th element would have been, or the element with square braces 100. And we're typically going to see a garbage value printout, or maybe even cause the program to crash, depending on what's happening. So in this case, it prints out 0, which means whatever storage location it's bumping into, it has the value 0 stored there. And if you change this, say we did 1,000, and then ran that, you may not see 0 again print. You probably see some other garbage value. Yep, we see this garbage value stored there. So again, be wary of going out of bounds or out of range in an array. That's a very common mistake when you're first coding with them, especially towards the beginning and ending, until you get used to array indices beginning at 0 and staying less than the size of the array. It's very easy to attempt to access out of bounds at the beginning and ending of them. So that's just the basics of arrays. In our next lesson, we'll talk more about using loops to process arrays.